Alrighty, well, welcome back. So the next step in our venture here is to try to figure out how we can come from our little stopwatch to something that can be a reaction timer. So for that, we first need to think again in terms of what is it that sets a reaction timer apart. Well, first of all, let me change the name of it so we know what we're working on. But seriously, the pressing of a button for ending is probably still the same. Right? If you think about how a reaction timer works, there's some form of random event that starts the clock, and then you indicate that you're reacting, and that stops the time, and then we again get the difference. So the part here where we have our button B press, that is the stop of the timer, that remains the same. The thing that we need to figure out now is, well, how do we randomly come to a start of the time? Well, for that, we need to figure out a way to randomize. So let's have a look at where we can find something to create randoms. And math is typically a good way. And if you look, oh, okay. So there we can have a random true or false, or we could have a random number between 0 and 10. Well, those are pretty good things. So let's go with sort of a very simple coin toss. Right? So let's say randomly we're picking a true or a false. And then we say, if we picked true, then we would like to start our timer. So for that, what we need is some form of logic, something that says, well, if this random pick turns out to be true. So we're going to logic, and there already is something that allows us to match the blocks here and say, well, if we pick randomly true, then, now let's just move this over, and then we can delete this. And now we have a part where, well, if this is true, right? So if our random coin toss says heads, let's say, then we want to start our timer. So let's put this into our forever loop, because our start loop is really only there to set things up in the beginning. So we have something that randomly starts our timer, but the problem is that this is run over and over and over. So we need maybe something in addition. Maybe we need something that says, well, if we did currently not start our timer, then, and if you checked, I pushed the little plus button, then, well, maybe we want to sleep a little bit, or we want to do something else. So let's see again where we can find our different things. Well, here we can find under basic something that is a pause. So why don't we say we pause, and instead of just pausing for 100 milliseconds, let's just do a second. So if our coin toss did not come out with a win and we start our timer, then we pause for 1 second. And because we are in this loop that runs forever, the problem is that we're then coming back here. The way that these blocks work, though, is that even if we started the timer, we are cycling back through to the beginning, and we're having the same issue again. We will again now pick and run through. So what we need to do is we need to figure out a way and a mechanism to only go through this particular if-else construct in the case that we are currently not running our little reaction time experiment. So if you think a moment, or 2 or 3, we can pause. I'm coming back now. So one of the ideas could be we can utilize the fact that, well, if our start time has a value that is larger than 0, because our running time will be larger than 0, then we want to go through this. Otherwise, start time is actually currently in use as a variable, so it will contain the running time here. Which means that we want to make sure that start time at one point can be 0. So we go back to variables, and it's typically a good approach to set things up for every variable. So let's say here our start time we set to 0, and we set our stop time to 0 in our onStart. Now we know that once we are hitting this, the start time will not be 0. So we could use that as an additional logical check where we say, well, if, and now we have to go back and we have to evaluate, we have to make a comparison. And this comparison has to be between our variable start time there we go. And we want to ensure that our start time is larger than 0. And only then will we go in and do our random coin toss. If our random coin toss is successful, then we start our timer. If our random coin toss is unsuccessful, we sleep for 1 second, and then we are going back to the beginning of our loop. If start time is 0, we're doing a coin toss. If the coin toss is true, then we're starting our timer. Otherwise, we're again going here, sleeping a second, and we're coming back. Okay, so from a logic point of view, we now have the start timer correct. There's one more thing missing, and I let you think for a second or two about what that might be. Okay, how does the user know that we're actually starting this game? the reaction timer, we need still to indicate somehow, once we start our timer, that we are playing our game. Feel free to design your own or pick any of these. Just going to go with the heart here. And if you want to be nice, you can shave off a couple nanoseconds for the user by first showing the icon and then starting the timer. Now we have to press button B, and then again everything stops. Remember though, our forever loop is continuously running. Oops, and I did make a mistake. There, should have been. Our forever loop is continuously running. So this is a one-shot game. We could turn this into a continuous game if we are bringing back pressing both buttons, and when we press both buttons, we could just go ahead and set both our timers here back to 0. All right. Let's recycle this. Let's be. And you can see I have a pretty abysmal reaction time. Now you can download this and run it, and you could also see this output on your computer.